about having up to 18 minutes of the talk and then about 2 to 3 minutes questions to the talk itself. And afterwards we're sitting together here and then we have more general talk, some more general questions to see how it works. So, and all 4 speakers are here. So we made sure that everybody is here, so nobody else has to give the talk about somebody, about another paper, so everybody gives his own talk. And I would just say, you start yourself, say something about yourself, and let's start. Please.
Thank you. My name is Yipeng. I'm from Shenzhen University. I got my PhD degree from Chinese University of Hong Kong. In my research, it focuses on content distribution, modeling, and analysis through complex network. We're glad to have a chance to introduce this work to you. So in this work, we studied how to detect fake news in online video systems. The authors in this paper are Chen and Professor Chiu. First question, what are fake view? Fake view is a view count created by a non-human. View count is the number of times video is played by users in certain period. The view counts are very important for the video systems. For the users, the view count is a recommendation reference. Users would like to view the videos with higher view count. For the content owner, they will use the view count to calculate video popularity. For the advertiser, the view count is money. Fake view doesn't exist in today's video systems. There's a news in 2012. YouTube claims that they have killed billions of fake views created by music industries, including Universal, Sony, EMG, and RCA. It's not clear how the YouTube detects fake views. We will study how to detect fake views automatically in the Chen video system. Chen video is the largest online video system in China. It's the outline of my talk. First, I will introduce the background of this problem, including the platform, Chen video system, and the motivation to create fake view and the method to create fake view. And then I will propose an algorithm to detect fake view from the user dimension, IP dimension, and video dimension. We thus also find fake views in the Chen video system. This figure shows user's daily view pattern. The x-axis is the time, and the y-axis is the percentage of views normalized by the total views of the day. The view curve is a normal user request pattern. The peak hours always occur at about 21 o'clock. It will repeat almost every day. But someday we find the peak hour is shifted significantly from 21 o'clock to 12 o'clock. By further checking the videos requested at 12 o'clock, we find that there are millions of requests created by a few machines for a particular music video. We believe these views are fake views, since normal users cannot create views with such high rate. What's the motivation to create fake views? List 2 motivations here. First, fake view can attract eyeballs. Our video system will rank videos based on the view count. By creating fake views, the rank can be raised. So with higher rank, a video can attract more user attention and become more popular. So fake view also make an impact. View count is referenced publicly, and the content owner can get benefit from high view count. But there are a lot of negative impact brought by the fake views. For network resource allocation, the seeding companies design the video replication algorithm based on the view count. With incorrect view count, the seeding resource may be wasted. Secondly, to generate fake views, a lot of the video views will be created, so it will increase the scheduling load. The recommendation algorithm also depends on the knowledge of the view count. It will also affect the business operations, such as we don't know what are the very popular videos in the system. And fake view also affects end users. They will feel triggered if they view a boring video with high view count. Who are making the fake views? In our study, we found that at least 5 parties in this ecosystem. The video service provider and the video viewers are attacked by the fake views. The fake view vendor, fake view buyer, and the cracker work together to inject fake view. The cracker knows the video architecture, video system architecture, and the communication protocol. They design tools and sell them to vendors. Vendors sell these tools to buyers, and the buyers use tools to create fake views. To detect fake views, we also need to know how the video system works. Take country video as an example. There are more than 50 million active users. In the peak hours, there are more than 2 million users. And this figure shows the whole architecture. This is a very typical architecture used by many video systems. The users will first send a request to the front-end servers, which will redirect these requests to the CDN companies. Then CDN will deliver the video content to users. Since users begin to view the video, they will send reports to the log server. Log server, based on these reports, to calculate the video view count. In such a complicated system, how to create fake views? Everyone can find such tools by Google buying views. Generally speaking, there are 2 types of approach. The first approach will use tools to create artificial views of forged reports. The second approach will use distributed network by scheduling tens of thousands machines deployed in different locations to send requests for a particular video. It's like a DDoS attack. This table summarizes the rated fake view created by different level of tools. The first tool will creating artificial views will open video in the browser tabs, and then view the video a short period and close the video, and then send the request again. Since the video viewing video need computer resource, the rate is limited. From a single IP, the fake view rate is no more than 10,000 per day. The second tool will never view any video. They just send out forged reports to the log server by cracking the communication protocol. So these tools can create fake views with very high rate. From a single IP, the rate can be, the fake view could be more than 10 million per day. So that's why we focus on studying the tools creating the forged report. We need features to detect fake views. We list 4 relevant features here. Intuitively speaking, if a user creating fake view, the user will send too many views. So the number of views and the request frequency should be effective to detect users. But in the video systems, users do not have to provide user ID to request videos. In other words, it's rather difficult to identify users. So in our study, we mainly use the other 2 features for fake view detection. This figure is a format of the report sent from the user to the log server. Log server just use this report to calculate the view count. In this report, the user ID could be blank, but the IP address and the video ID must be true. So our idea is to use the user-based features for observation and use the IP-based feature and video-based feature for detection. So this matrix is a summarization of the user's view patterns. Each element, AIJ, is the number of times the user I view video J. If a user creating fake view will send many views for a particular video, then we can capture that by by the entropy function. So based on each user's view pattern, we introduce the entropy function defined on the right-hand side equation. From our measurements, we find for most users, the probability to replay a video is very low. So according to the property of entropy function, it should increase logarithmically with the view count. And for users view focus on a particular video, the entropy value should be very low. So we plot all users' entropy in this figure. Here the x-axis is the view count and the y-axis is the entropy value. Each plot represents the user. Apparently there are two groups of users. The first group, the user's entropy will increase with the view count. For the second group, the user's entropy is almost flat. By manually checking these users, we will find that it's highly possible those users with low entropy are creating fake views. So from our experiment, we believe the entropy is effective to detect fake view. So we define entropy, IP entropy and video entropy in similar ways. But the challenge is that because of the existence of NAT, it's possible that multiple users will share a common IP address. That means it's normal that an IP will replay a video again and again. So the entropy value of the IP address and the video will be lower than the bound, even by the view count. Here this matrix is the IP view pattern. Here the element of IIJ is none times the IP address I view video J. So similar to the user entropy, we define the IP entropy based on the IP's view pattern. Then we plot all IP's entropy value in this figure. Here the x-axis and the y-axis have the same meaning with last figure. Each point represents a figure. We still have two group IP addresses. But in the first group, there are many IP addresses with very large view count. We believe they are NAT IP address. Meanwhile, there are many IP addresses in between the two groups. So these IP addresses are suspicious to creating fake views. To precisely classify these IP addresses, we need to use machine learning approach by considering more features, such as the video entry. In this equation, we first define the video entropy still based on the IP size matrix, and plot all the video entropy value in this figure. Here, the x-axis is the view count, and the y-axis is the video's entropy value. But we first manually checking 10,000 videos, and then use the TSVM to classify all these videos. We believe the videos below the straight line are those videos affected by fake views. Now together with the video entropy, IP entropy, and view count, we run TSVM again to classify all these IP addresses into normal IP address and IP addresses creating fake views. And we also check the classification result manually and find that the accuracy is about 99%. So now I summarize the observations from our experiment. For most fake views, they are from the videos belonging to the type of user-generated content and music videos. But some popular TV series also introduce fake views. For user-generated content, the video creators have incentive to promote their videos. But for music videos, to promote a star, the public relation company and the fans have incentive to introduce fake views. This table also gave 3 typical videos affected by the fake views. For the first video, it belongs to user-generated content, and all their views are from a single IP. For the second video, it belongs to the music video, and almost all their videos, all its views are from 6 different IP addresses. The last video is a TV, and more than 60% of its views are from 10 different IP addresses. Finally, I will conclude my talk. In this work, we introduce the problem of fake views. And we also propose algorithms to detect fake view based on IP entropy and video entropy. For our future work, we have 2 challenges. Distributed network attack is not covered. And secondly, we also need to design an algorithm to detect fake view in real time. Finally, there is an advertisement. Also, this paper is about position. This is, if you have interest, please comment.
Okay, thank you very much. So you're advertising, looking for a postdoc position. That's good. That's good. So, and you're right in time, more than in time. So if we have any questions, we are open to any questions.
A quick question. Would you like to say something about IPv6 versus IPv4?
So in China, we mainly use IPv6, V4. We don't use IPv4. 6.
Would it make any difference?
So there's no difference in our work.
Question. So you said the user ID is optional in most of the reports that come back to the box server. So how? I mean, do you in your first results you actually show user entropy? Is that only for the subset that has user ID?
Yes, the user entropy is calculated from a subset.
Okay. How big is that subset?
No more than 20%
Okay.
of total views.
Is there and the results for the IP address-based ones, is it for the same subset or is it for a different?
It's a whole set.
It's a whole set.
Is it more common to track the communication to the provider servers, or to introduce fake views just by botnet or something like this? What is more common?
I think you choose to crack the protocol is more common.
That's more common. Is it that easy to crack the protocols?
I think it's not difficult for crackers.
I have a question about the effects of the midbox. There will be a midbox that can make multiple requests, make into one request or something, or caching. Does your method also consider about that effects of the midbox? Well, I think the ISPs or other networks, there will be a midbox that can reduce the traffic or make multiple requests, multiple same requests into one. And I think that those things also can be fake accounts. And does your method also consider those effects?
So the ISP can detect those fake views? Or the ISP faces a similar problem?
Douglas, you have a final question?
Yeah, just curious, can you use like multi-dimensional entropy to detect the distributed stacks? I was wondering if you could use like some kind of higher dimensional entropy to detect the distributed
How many manually detect this video?
transmitted at the time of arrival across something like that?
We use the frequency, time of arrival.
Or some kind of entropy of just the overall time of arrival or something to affect the pothead type. All of it, you had 1,000 views that all came in at one.
But the frequency request arrival is complicated. It was can send request to random
Okay, thank you very much. So we're going for more questions at the end. So thank you again very much for all about the take. So we're going about multiplayer online.